Welcome back to day 50 of your Python course by Edulexis. Today, we are deep diving into date and time manipulation. Why is this important? Think about booking a flight, tracking when a user logs in, or setting up reminders in an app. Python handles all of this easily using its built-in modules. If you've ever struggled with planning timelines or tracking deadlines in code, don't worry. Today, we will make it very simple and easy to understand for beginners. Let's get started. Before writing code, let's understand the structure. Python has a built-in module named Datetime. Inside this single module, there are three primary classes we use most often. First is date, which handles only the year, month, and day. Second is time, which tracks hours, minutes, seconds, and microseconds. Third is datetime, which combines both into a single object. Understanding these three building blocks makes everything else straightforward. Let's look at the first class, date. To use it, we import it directly. Look at the screen. We create a date object by passing three numbers in order: the year, the month, and the day. When we print this object, Python displays it in a clean, standard format: year, dash, month, dash, day. Remember, you must always provide valid numbers. Passing an invalid month number like 13 will cause Python to show an error. Once you have created a date object, you can easily pull out individual pieces of information. You don't need to do any complex text searching or manipulation. You simply add a dot followed by the attribute you want, like .year, .month, or .day. This is very helpful when you want to build logic around specific months or filter database items by a certain year. Next, let's explore the time class. Just like the date class, we import time and pass the specific details we want to set. We specify the hour, minute, and second. Python uses the 24-hour format by default, so passing 14 means 2 p.m. If you don't provide seconds, Python automatically sets them to 0. This class is ideal when you care about the time of day, but the calendar date doesn't matter. Now, let's combine them using the datetime class. This is the most popular choice because it captures everything at once. To get the exact current moment on your computer, we use the method datetime.now. When run, it prints the full date followed by the exact hour, minute, second, and microsecond. This is exactly how production apps stamp the time when a new database record or message is created. What if you want to add or subtract time? For example, figuring out a due date. That is exactly 7 days from now. We did this using a class called Timedelta. A timedelta represents a duration or a change in time. Think of it as a bridge that moves you from one date to another. Let's see how we can use this to perform basic calendar calculations instantly. Look at how clean this code is. We take our current time object, use a simple plus sign, and add a time delta of 10 days. Python handles all the calendar heavy lifting automatically, including shifting to the next month or managing leap years. To find a past date, you simply use the minus sign instead. It behaves exactly like standard math, which makes it very intuitive. By default, Python displays dates in a very rigid format to present dates. Beautifully to your app users, we use the strftime method. The lef in strftime stands for format. This method lets us convert a date object into a customized text string using special percentage codes. For example, %Y gives you a 4-digit year, %M gives the month, and %D gives the day. Let's explore a couple more helpful formatting codes. If you use %A, Python outputs the full name of the weekday, like Tuesday. %B outputs the full name of the month, like July. By combining these Symbols with regular text, spaces, or commas, you can make your software. Display friendly sentences like Tuesday, July 7th instead of just raw technical numbers. Now, let's reverse the process. Imagine a user types a date into a text box as a regular string, like the 25th of December, 2026. Python cannot automatically do math on plain text. We must convert that string back into an official datetime object using strptime. The P stands for parse. We provide the text string first, and then tell Python exactly how to read it using our percentage tokens. When parsing user input, things can go wrong if someone makes a typo. If the input string doesn't match the format code you defined, Python will throw a value error and stop running. To keep your app running smoothly, always wrap your parsing code inside a standard try except block. This allows you to catch the mistake gently and print a helpful instruction to the user without crashing. Up until now, our datetime objects have been naive. This means they contain numbers, but Python doesn't know what geographic time zone they belong to. If your app is used globally, this can cause confusion and go where the datetime object, on the other hand, explicitly contains time zone details. Let's look at how Python manages this safely using its modern standard tools. In modern Python, we handle time zones using the built-in ZoneInfo module. By passing a standard region name, like America New_York, into ZoneInfo, we can find out the exact local time in that specific area instantly. This approach ensures your applications stay highly accurate, even during regional daylight saving shifts. To wrap up day 50, your challenge today is to build a simple milestone calculator. Take a future target date, subtract today's date from it, and print exactly how many days are left. We covered a lot today, making dates, calculating time changes, formatting strings, and setting time zones. Practice these examples on your own computer. Don't forget to like this video. Subscribe to Edulexis, and I will see you in the next session.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.